So the first part of these notes are a review. The expression log x represents what kind of log and what is the base that's missing? That's correct. It's not normal. Common log. So this is a common log. With a base of 10. So a 10 is here if there is no number. What about this one? What is this called? What's the next one called? What's this next one called? LN. Dig out your notes. I'm not going to tell you. So this is in our notes somewhere. Natural. Thank you. Yep. Bonus points to anybody that knows what E stands for. It's somebody's name. No. It was written on the board for a minute. Euler. It's weird.
Euler?
Mm-hmm. E-U-L-E-R. But you pronounce it Euler. It's weird. It's kind of weird. It's called Euler's number. That's what the E stands for. It's an actual number. But moving on, we don't have to know what E stands for. We just have to know that it is E. The next, and it's a button on the calculator. At some point today, when we take a 5-minute homework break, you're going to need to get up and go get a calculator because we're going to need calculators for the last part of the note. It's a number 2.71, I believe. It is a number. Hmm? Here. The solution to any graph, every graph, any graph, every graph, any graph, and I think that this is the last part of your review. This should be the easiest part. So you can rack up a couple questions pretty quickly. Question 38 through 43. You can do all of these when we take a break and I give you homework time. The last page, all of these solve exactly like what we're going to do right now. The solution to a graph, solution, is where the graph crosses the x-axis or the x-intercepts. That's it. We've been doing this all year. Here's a new function. Find it on a graph. It's the x-intercept. Here's a new function. Find the solution on the graph. It's the x-intercept. Here's a new function. Find it on the graph. It's the x-intercept. It doesn't matter what kind of function it is. The answer, the solution, is the x-intercept. For all these problems, first you have to draw the asymptote for these exponentials. You also have to draw the asymptote for these logarithms. The asymptotes are going to be just lines, little dashed lines. So the asymptote for exponentials is going to be a horizontal line. The asymptotes for a logarithm is going to be a vertical line. And the line's going to go just right underneath where the graph is leveling off. So this one, it looks like it's going to go. Oh, also you can tell when you have the equation, that one, the asymptote's going to go at -4.
For the logarithms, it's vertical.
Yeah. For the next one, it's like +0. So the asymptote is at 0. So that's the first part of the question is asking, or sorry, the first part of answering this question is drawing on the asymptote. For the logarithms, it's what goes with the x and its opposite. So when you see -2, that's why it goes to +2. And this one is like +0 in there because there's no plus or minus, so it's at 0. So drawing on the asymptote, being able to draw it on, you can look at the equations or really you can just look at the graphs. The second part of this is identifying what those x-intercepts are. So for the first one, where does it cross the x-axis?
2.
Yeah, just right there at 2. So my answer is, sorry, my page switched. The answer is x equals 2. For the next one, where does it cross the x-axis?
Never.
Never. So we would say that this is no solution. For the next one, where does it cross the x-axis? 3. And the next one? 1. Very good. Easy, right? So everybody should be able to give me the answer or the solution to a graph. And it doesn't matter which kind. You can give me the solution to a graph. So I'm going to give you a 5-minute timer. You can not only do the homework questions, draw on the asymptote, but you can also probably in that 5 minutes do these 6 problems on your review. Okay, so I'm going to give you a timer.
I need one more.
Yes.
Neil, I'm gonna get this. Yeah. Yes. Where did it come from? Yeah. How did that help again? Yeah, I did. You did that thing? Oh, and it's probably right. I didn't know. Yeah, exactly. No, it's all good. I could probably do that soon. Yes. I would do it. What's extraneous?
Extraneous, extra.
Bonding interest in.
No. Because we did the law of the negative number. Does it cross the x-axis? This comma this? Oh, it doesn't have an asymptote. That graph doesn't have an asymptote. Neither does 43. Those don't have asymptotes.
I just said. That's glasses. I have the After the thing, bro, where did it cost? The things where you have to grab it. Where did it connect the dots and it makes a picture? Oh, yeah. I know, but they're so like, yes. So, like, what? You didn't notice? Five things in a hurry. What do you know? I need my money. You got the fun song. Oh yeah. Wait, what? Yeah. Good festival. What kind of tips do you have? I'll do one. No, for some reason, no one's been doing. The Republic? No, yeah, yeah. Just the small ones. There's more in. Damn. In the small ones, it's like, it's a lot. There's no service. This one. And I had.
All right, let's regroup. So now we're going to talk about something that you've already kind of been doing. So the next thing that we're going to talk about is the property of equality for exponentials. The property of equality. The property of equality for exponentials says that if you have b to the x equals b to the y, that's true if b is bigger than 0 and b is not equal to 1, if and only if blank is equal to blank. So this only works if, so b is equal to b, we remember that those cancel out and we're left with what equals y? X equals y. So to give you an example, when the bases are equal, then we set the exponents equal. So we end up with x is equal to 5 for that little example. Y'all remember this? We've been doing this.
Yes.
Yeah. So the next problem, or sorry, for our examples, if the bases are the same, you just start working the problem. For this one, 4 and 4, the bases are the same, so they cancel out. And the property of equality says I can set the exponents equal. 3x minus 5 equals 10. This is a two-step equation. What's my first step?
Plus 5.
Yeah, we'll have to add 5. Yep. Yep, and then we have to divide by 3 and x equals x equals 5. You could check your answer. You'll have access to a calculator, not just today during class, but also on your assessment. So you could plug in 5 over here. 3 times 5 is 15. 15 minus 5 is 4 to the 10th, which is equal to 4 to the 10th. We did it correctly. The next problem. If you do not have equal bases, let's make them equal. This is where your exponent chart comes in handy. Can we rewrite 9 as a base of 3? Yep, 3 squared, but there's already a 4 there, so we have to multiply that by 4. Yeah, so we get 3 to the 8th is equal to 3 to the x power. Now that we have our bases equal, we can mark them out and set the exponents equal. So 8 equals x. And again, you could type this in the calculator to check. You could type in the calculator 9 to the 4th power, and it will be the same as 3 to the 8th power. Next problem. Yep.
Is it okay if it's x equals 8?
I don't care. If you like it better like this, if this makes your life complete, then please write it like that. For the next problem, our bases are not equal, but we can make them equal. Can we rewrite 4 as a base of 2? How? 4 is the same thing as 2 to what power? Mm-hmm. And there was already an x there. Anything that's already has an exponent, it just multiplies together. So now that my bases are equal, I get to mark them off. When the bases are equal, the property of equality says that I can mark out the bases and I can set the exponents equal. So I get x plus 7 equals 2x. There's several problems today that we're going to work that have x's on both sides. When you have x's on both sides of the equation, take a look at both of the x's and you're going to move the x's towards the bigger one. So I have 1x on this side and 2 on the other. Which one's bigger? 2. So let's move the 1. So I'm going to move over the 1x and subtract 1x. So I get 7 is equal, 2 minus 1 is 1, or just x. So I get x equals 7, or 7 equals x. Whichever way you like it, it doesn't matter. So property of equality for exponent, or sorry, for exponentials. If the base equals the base, we mark them off and we set the exponents equal and solve. From there, it's just doing algebra to solve the equation. Does everybody understand the property of equality for exponentials?
Wait. So why did you do 3 squared times 4
3 squared times.
in the second one?
Oh, because there was already a 4 there. There was 9 to the 4th power. And so I rewrote 9 as 3 squared. There was already a 4 as an exponent, so anything that's already there will multiply. So like this next one, there was something as an exponent too. I rewrote 4 as 2 squared, but there was already an x there, so they multiplied. The property of equality for logarithms is pretty much the same. The property of equality for logarithms is pretty much the same. So if b is a positive number other than 1, and you have log base b of x equals log base b of y, this works if and only if what is equal to what? What do you think? X equals y. And this works because if your log bases match each other, same thing happens with exponentials. If the base equals the base, you can mark them out. And this only works if it's log equals log. Can't have anything else. And that's the same thing that we noticed here. There wasn't a plus or minus 4 or anything random over here on the side. It was just an exponential equals an exponential. Same thing has to happen here. It can only be log equals log. And so here's an example. If I have log base 5 and log base 5, the bases are the same. If they are the same, I can mark out the log part and I set the stuff equal. So I get x equals 8. So for the first problem, the base matches the base, so I can mark it out and set the stuff equal. All right, this is a simple one-step equation. What do I got to do to get x by itself? I don't know why my looks like that. Look like a 13. Yep, I just need to divide. So I will divide by 3. What's 30 divided by 3? 10 equals x, or x equals 10. Should you like it better that way? For the next problem, I don't see a base. What is the base if it's not there? 10. And what kind of log is that? Common log. And if the bases are equal, then we can mark them out and set the stuff equal to the stuff. Here's another problem where we have x's on both sides. I have 1x and I have 2x. Which one's bigger? 2. So 2 is bigger, so I'm going to move the x's to that side and the numbers to the other, and I'm going to do that in one step. So one step, I'm going to bring this x over and say minus 1x. And in the same step, I'm going to bring over the 8 and subtract 8. 2 minus 1 is just x. 5 minus 8 is negative 3. Did y'all get the same thing?
Yeah.
Awesome. And for our last problem, this is a natural log. What's the base for a natural log? E. Let's just get practice writing it. This is called a natural log, base of E. And when I have log equals log, my mouse is being crazy. Log base E equals log base E, or natural log equals natural log. I can mark it out and set the stuff equal. All right, this one's going to be, does somebody fart over there? Yeah?
Yeah.
It's getting funky. That could really disrupt notes.
It does.
Tariq looks like he's about to vomit. I would say that you probably did a great job, Derek. Good job with that. So for this one, it's going to solve a little bit different. Anytime you see something squared, we're probably solving it like a quadratic. And so what we're going to do is bring over minus x. We're also going to bring over and subtract 20. And so I'm going to have it all set equal to 0. This one solves a little special. So I get x squared minus x minus 20 equals 0. I know it's weird, but this is where we draw on our super skills. We've learned how to factor, and we factored and we factored and we factored. So we are going to factor to find our solution. So we're going to think of two things that can multiply to give me 20.
5.
Yeah, 5 and 4 will work. So I'm going to put x and x, 4 and 5. 2 and 10 do multiply to give you 20, but they can't put together in such a way to make me, oops. I can't put it together to make me 1. Yeah, I have to put it together to make 1. So to make a negative 1, I have to make my bigger number negative. So I'm going to make the 5 negative. And then if I have negative 5, I would have to add 4 to make negative 1. And 4 times negative 5 gives me negative 20. So we factored correctly. What do the x's equal? Here, if these are my two factors, what does x equal? Negative 4, positive 5. All right, we've got a note here at the bottom. You can't take the log of a negative number. Logarithms, the ones that we did before with exponentials, those don't matter. Like this only works for logs. You can't take the log of a negative number. And so what that means is we're going to just spot check all of our numbers and think about if we plugged them back into our equations, would we be taking the log of a negative number? So here, I don't have to look here because it is log of 30. That's positive. But I have to look over here. If I plugged 10 in, would that make a negative number? Is 3 times 10 a negative number?
No.
No, it's fine. These answers work. Over here, if I plugged in negative 3, 2 times negative 3, that would make negative 6. 8 minus 6, that's still positive. Over here, 5 minus 3, that's still a positive number. Over here, if I plugged in negative times a negative will give me a positive. Okay. 20 minus 4 is still positive. And if I plug in a positive, it will stay positive. So do you see what I did there? I just plugged in the values to make sure that what I'm taking the log of would still be a positive number. It doesn't happen often, but it can happen that you're taking the log of a negative number. And in that case, that solution doesn't work. So sometimes no solutions work. Sometimes, like with that third example where I had 2 possible solutions, it's possible that one works and one doesn't. But you can't take the log of a negative number. That's something that's important to take note of. Okay. I'm going to give you more homework time. So at this point, you can go through and you can do problems on your homework through question number 18, really. You can go through and you can start working problems through question 18. So I'm going to give you 15 minutes. Yes. Is there a bug? What? Y'all want to hear something gross? My daughter her class for UTSA it's an oceanography class, so they went down to Corpus and her and her wife got this hotel. They were going to stay, and then she woke up today to go out like in the ocean and collect like ocean samples. And they are really compulsive. They were checking the bed just to make sure it was kind of it seemed not as clean as the pictures. There were bed bugs. There were like actual bed bugs in this hotel.
Wait, you can see bed bugs?
Yes, they're small, but you can see them. Yeah, so they were in that room for like 5 minutes, left, and had to go to a different hotel. I'm sure they did. It was like $250 to stay there. So no, they got their money and had to go somewhere else. Yeah. That's crazy. Like that's something that you hear about, but you don't think happens to real people. But it did. It did. So check your beds. Definitely check your bed. Yes, take the path.
You don't know how to do this? First thing you do is no. Yes, but
you check and say
the base example.
that's 5.
Yeah, that's bigger. I can find it and put it over here.
I know. And I know you is. I was like, those one over there.
The basic.
What exactly you do? That's it.
All y'all were drawing.
I think job well done. If you can clear out a whole table, like pat yourself on the back for that one. I think parts are funny. I think it's
Are you here smelling it?
No.
Don't.
But I think it's pretty funny. Y'all all scattered like cockroaches.
I thought they were like all of that. Like Jack did, like we told Jack about the atomic bomb.
Oh. 3 times 3. No, not what.
Oh.
It's in.
Alright, nice.
Wait, this.
Yep.
Oh, now you take off the bases. And then you do x equals
3 times 3.
3 times 3.
So the exponents, do we actually do, like, if we move it aside and then put, like, what for putting 9 squared,
Which problem are you working on?
4? I put 4 to the power of 3 times 3. And
So
then
it's 4 to the power of 9.
Well, actually, don't. Oh.
X.
4 times equal. There's actually no version to X out. And
He's a fighter. He is a fighter.
what is this now?
Okay, no, that's great.
I'm already dead, yeah, it's very good.
See, the long ones I don't think. Oh. Zero. 2 separate points.
When I say 0,
Zero.
there's 10. 10 is 0. Oh.
Miss Patrick, this charges collation.
That's what it is. Watch it.
Quick.
That's 100 damage. Wow, that's such a big factor.
What is it? Or is it, yeah. X equals 4. So funny, bro.
Let me get it back at Chips Mazzaro. I don't want Chips to be much.
Wait, what happened? That's not.
Hey, man. It's also really late for this. I'm actually surprised you have this.
Read.
Wait, do crosses out that?
Yeah, what's your favorite? As long as they're the same.
So what's the 7 equals -7? So it's 1. 7 equals -7.
No, you said that one more.
Oh, I didn't see the X.
Well, those are completely. Fair enough. So it's.
What is it?
Wait, what?
That was
This.
Did you see it?
Yeah.
Whatever we're studying.
On number 8, it's gonna turn into a fraction if I do it. Is that right?
That's.
Or did I do something?
So when it's like, I don't have.
Even a difficult fraction.
Not at all.
Before.
It's the way they cut you. It's what it's.
I was once like you.
One side.
I was once like you.
Alright, I have one more question. Yeah. No.
What did that say?
Negative number. What? What's so funny?
You can picture it handwriting.
It says negative. What else would it say?
Oh, this.
That says number.
I know. It doesn't look.
NUMBR.
So I see it.
I didn't think it would be that.
But the fact these things are talking to him.
Double was her.
At school.
Yo.
It's all. Oh my God.
Look, you have a big distinct. This area. No, this is bad and then bad.
Every time I go in there, someone would, oof, open in here. No, do you have,
I use Avatar.
yeah,
I know the rest.
yeah, the rest, the rest. Meant to say rest.
If it's me, it's the same thing.
No, you use it. Oh, wait, I'm not done. Then you're a little late, bro. You can't do this.
We're gonna be nothing more than say. Stop service.
You don't know about me yet.
Then what's the?
I think we're gonna learn about it. We can do that.
What was those?
Oh, guess what? Guess what?
Yeah, was it-
You know the winter. Yeah. So that's I fold Coleman. You fold Coleman. Readable.
800. 800 mil for
Wait. What is overall? No rank, no nothing.
No rank. I think the starting rank is 105.
That's mine.
You have it?
I have it. No, I had the Tommy one.
Yeah.
Either one of my numbers.
Yeah.
Go to the phone.
Probably your stomach hurts. No, he's trying to refill. He's gonna get one.
Oh, wait, no, -6.
Dang, this probably can't have nice things. Probably can't have nice things. Yeah,
That's actually a nice thing. Yeah. And then
That's why I would say.
and then a 28.
Yeah.
And then.
Ooh. Then the factory backing.
It's y'all. Look, it's the keys.
Good. Oh, sorry.
Don't worry. I already know that is. Oh, I already set these up.
I did one.
At least 10, 11.
You might go.
What are you doing? You just set up the. Four to the fourth, no, second from there. It's second.
One, two,
Four to left.
From the thing, right here. Oh, like this out.
I think it was in there.
All righty, let's finish up. We're almost done. There's just one more thing that we need to go over. Where's my mouse? There it is. There's one more thing that we need to go over, and it's talking about if you have two logs with the same basis, if two logs with the same bases are on the same side of the equal sign, let's combine them. And we've learned how to do that. Two logs with the same base are on the same side of the equals, combine them. Or condense them. Sorry, let's use that word. Let's condense them. Let's write condense. That doesn't feel right. Is condense with an S? Does that feel more righter? In any case, y'all know what I'm talking about. We're going to combine them together or condense them. I know how to say the word, even if I can't spell it. We're going to condense them, and we're going to use the properties that we already know. We're going to use that when you have two logs and you're adding, you'll combine them to multiply the stuff. And when you have two logs and you're subtracting, you're going to combine them and you're going to divide the stuff. So on the left, example 5. And we just took a quiz over this. So these two logs, they are on the same side. We want to condense them. It's adding, so we're going to multiply the stuff. Well, we don't have just variables. We have a 4 and an 8. What's 4 times 8?
32.
Okay, so we get log base 7 of x equals log base 7 of 32. When the bases are the same on both sides, let's mark them out and set the stuff equal. So we get x is equal to 32. Not much work involved there. Easy peasy. The next problem, we've got two logs. They're on the same side with the same base. They're subtracting. We're going to combine them. And when we combine them, we're going to divide. So we get log base 4, 16 divided by x is equal to log base 4 of 8. The logs have the same base, so I can mark them out. And I'm going to set this stuff equal.
The interruption teachers. Substitute teachers in classroom today. Attendance rosters if you haven't done so already. Once again, all substitute teachers, please send down your attendance rosters if you haven't done so already. Thank you and have a great Panda Day.
Okie dokie, to solve this one, we're going to switch places here. So I get 16 divided by 8 is equal to x. That's how I got x out of the denominator. And what's 16 divided by 8? 2. God, I don't know why my pen is being crazy. It's having a really rough time today. Let me try and unplug it. What? I'm trying really hard. Let's see if we plug it back in. I've had this pen pad. I don't know. Maybe it's called a tablet. I've had it since COVID. Yeah, I had to learn how to use. That's how I learned how to Zoom my meetings and stuff, or my classes, was during COVID. So we can also just double check that if we plug in our answers into the original logs, we want to make sure we don't get negative numbers. So for the first problem, these are both numbers, so we don't have anything to plug into. But here, if I plug in 32, well, 32 is positive, so that's good. It's an answer. Over here, I don't have to deal with 16 or 8, but plugging in right here, I'm plugging in a positive number, so that works. It's good. Like, I don't have any extraneous solutions. You do have to check for that, but like I said, more often than not, you aren't dealing with one. And our last set of problems, when you only have one log or exponential, you have to rewrite the problem to solve. When you only have one log or exponential, you must rewrite the problem to solve. Maybe my pen is just being crazy. Okay, so on this problem, I don't have the property of equality. I don't have base equals base. I don't have log base equals log base. I cannot just mark things off. So I have to rewrite this logarithm. I have to rewrite it. And so we're going to use that backwards E thing to rewrite it as an exponential. That's why we had to learn how to do that. So I'm going to rewrite it as 2 to the 5th power equals that stuff. 2 to the 5th power equals the stuff. And like I said, anytime that you have an x squared, we're going to solve it like a quadratic. So also we need to figure out what is 2 to the 5th power. 32. So I'm going to bring this over and subtract 32 because that's 2 to the 5th power. And as I go ahead and rewrite it, when I set it equal to 0, I can go ahead and factor it. What two things can multiply to give me 32 that can put together to give me 4? 8 and 4. So I'm going to put 4 and 8 in the boxes. The middle term's negative, so the 8 needs to be negative. And if I have negative 8, I would have to add 4 to make negative 4. And a negative and positive will multiply to make me a negative. Okay, so I have it factored. So what does x equal if these are my factors? Negative 4 and positive 8. So I need to just double check my negative one. I need to double check my negative one. If I plugged in negative, negative times negative will be a positive. And positive 16 minus negative times a positive, that will end up being a positive. So both of those solutions both work. And last, you're gonna need a calculator. You need a calculator for this one. Again, anytime you just have an exponential or log by itself, you have to solve it by rewriting. So this one we had a log and we rewrote it as an exponential. This one we have an exponential and we have to rewrite it as a logarithm.
Wait, what?
Yeah, for real.
Wait,
The other way that you can think of it is we're basically taking the log of both sides, but we want to take the log that matches. So what is the base here? E. So which logarithm matches with a base of E? Natural log, yes. So I'm going to make the natural log. Let me get pink. So I can take the natural log of both sides. This is the same thing as rewriting it. And what happens when the base matches the base? Yeah, so I'm left with just negative 2x on this side. So these will cancel. I'm just left with negative 2x on this side equals ln e of 2. All right, we want to know what x equals. We want to know what x equals. Well, guess what? To get x by itself, what would we do with this? How do we get x by itself? Ignore what's here. How would we get x by itself? Divide by negative 2. So that's what we're going to do. Divide by negative 2. All of this on this side, these are numbers. There's no more variables. X equals the natural log of 2 divided by negative 2. And you're going to type that in the calculator. Where's natural log? Well, it's along the left side of your calculator. Along the left side, you'll find the log button. Right underneath that is the natural log button. You press natural log of 2, close your parentheses, and then you put divided by negative 2. And it's going to give you a decimal answer, and it's ugly, but that is the answer, and that is okay. So what do you get as your answer? What do you get? You're not going to have any clue how to do this on the test if you don't practice and type this in. What do we get?
Wait, so all we do is just divide 2 with not the natural log or whatever.
We type in the calculator, natural log. The base is imaginary, like you don't have to write it. Like, not imaginary, it's invisible. You don't have to type it in. So you just press natural log 2 divided by negative 2.
Where's that?
At the bottom left. What? It's 2 above.
Oh, 2.
If you just type in natural log 2, close your parentheses, divided by negative 2.
What the? It's like negative.
What do you get?
This is what I.
Okay, let's round it to a couple decimals.
That's what you.
What do we get?
Negative 0.35.
I like it. So these problems where you have to rewrite it as an exponential to solve, those are definitely on your homework. Those are questions 19, 20, 21. The questions where you have to condense before you can use the property of equality for logs, that's not on your homework, but it is definitely in your review packet. So that is the rest of the unit. We are done with logarithms and exponentials until you take your final exam. Woohoo! And let's see, this is what we can be working on right now.